Good day, our dear students of senior high school. This is your on-the-air education on physical science for grade 12. We are happy that we are together, and let us enjoy learning through the use of modules complemented with radio, television, Facebook, and other online modes of learning. And I will be with you throughout this episode. Call me Teacher Junji Sabolboro. These are our objectives. Determine if a molecule is polar or nonpolar given its structure. And relate the polarity of a molecule to its properties. We are about to begin, so bring your module and find a comfortable place. Check your speakers if you can hear me clearly and ensure that your screens are unblemished. I encourage you to place a notebook, a ball pen, and a highlighter beside you, so you do not miss important information from the discussion later on. Also, prepare water and snacks, so you do not need to stand from time to time. Is everyone ready? That is good. We will now get down to our business. At this point, turn your module on page 13. Determine the bond polarity of the following compounds based on electronegativity differences and molecular geometry. You will only write the word polar or non-polar. Are you ready? Number 1. Hydrogen bromide or HBr. Is it polar or non-polar? Number 2. Phosphine or PH3. Is it polar or non-polar? Number 3. Silicon sulfide or SiS2. Polar or non-polar? Number 4. Oxygen gas or O2. Polar or non-polar? And then for number 5, boron trichloride or BCl3. Polar or non-polar? So, let us check your answers. Number 1, HBr, polar. Number 2, PH3, polar. Number 3, SiS2, non-polar. Number 4, O2, non-polar. And number 5, BCl3, non-polar. Congratulations! Before we proceed to our lesson, we have another activity on ionic and covalent bonding. You are going to identify the type of bond that exists between the atoms in each pair. Pair number 1, silicon and hydrogen. The answer is covalent. Pair number 2, magnesium and iodine. The answer is ionic. Pair number 3, fluorine and fluorine. The answer is covalent. Pair number 4, carbon and nitrogen. The answer is covalent. Pair number 5, sodium and fluorine. The answer is ionic. What have you observed from the given bonded pair of elements? For covalent bonding, it usually involves bonding between non-metal elements. While for ionic bonding, it involves bonding between non-metal and metal elements. Our lesson for today is all about the polarity of a molecule based on its structure. This time, let us unlock the following key terminologies. Polarity means having dipoles, a positive and a negative end. Based on polarity, molecules can be polar or nonpolar. Electronegativity is a measure of the tendency of an atom to attract a bonding pair of electrons. As a general rule, the higher the electronegativity, the greater an atom's attraction for electrons. Dipole moment is simply the measure of net polarity in a molecule which arise from differences in electronegativity. In determining the polarity of a molecule, we have to address the following 4 questions. First, how does bond polarity affect the polarity of a molecule? Second, how to determine the direction of a molecule polarity. Third, how does shape affect polarity? And last, how do elements on the outside of a molecule affect polarity? So what is polarity? Molecules are neutral. If negative charge is evenly distributed around the molecule, it is not polar. Example, CO2 molecule or carbon dioxide molecule. Whereas, if there is uneven distribution of negative charge, the molecule is polar. Example, H2O molecule or water molecule. Let's take a closer look on the water molecule. Let us examine its bond polarity, outside atoms, and molecule shape. First, the bond polarity. If the electronegativity difference ranges from 0 to 0.4, the type of bond is non-polar bond. Whereas, if it is greater than 0.4, it is polar bond. So, for water molecule, the hydrogen and oxygen bond polarity is polar bond, since the electronegativity difference is 1.4, which is greater than 0.4. Second, to consider the outside atoms. We have to draw the Lewis dot structure of the given molecule. Third, to consider is predicting the shape of a molecule. We could simply refer to the molecular geometry chart. In our example, using the Lewis dot structure, we could say that the shape of water molecule could be bent. Since there are 4 groups of electrons, or there are 2 bonded electrons and 2 lone pair of electrons on central atom. Another example is the boron trifluoride or BFL3. First, consider its bond polarity. Its BF electronegativity difference is 2. So the BF bond polarity is polar. Then, draw its Lewis dot structure. After that, identify its shape using the molecular geometry chart. So, its shape is trigonal planar, since it has 3 electron groups with no lone pair on central atom. This also means that all the angles between bonds is 120 degrees, exhibiting symmetry. Although each bond is polar, but adding it together just like a vector quantity cancel each other, yielding no dipole moment. So, it is a non-polar molecule. Tip: if a molecule exhibits symmetry, it is usually a polar molecule and vice versa. Moreover, as polarity increases, the melting point and boiling point also increases. In our previous discussion, I've shown the long method on how to determine if a molecule is polar or not, in which the first consideration is the bond polarity of each bond within the molecule. Second consideration is the outside atoms, wherein you have to draw the Lewis dot structure first of the molecule. And lastly, on how to predict the shape of a molecule using the molecular geometry chart. Additionally, you also need a little bit of knowledge on vector quantity to determine its net dipole moment. Only then, we could decide if a molecule is polar or not. Don't you worry, our dear students. I'll show you the shortcut or easier approach. Basically, we deem a molecule as polar if there are different terminal atoms, or there is lone pair surrounding the central atom. Notice, if either one of the statements is true, then the molecule is polar. It doesn't have to fulfill both statements. What if both statements are not true? Well, in that case, then the molecule is classified as nonpolar. Sounds easy, right? Let's try out with some examples. But before we start, let me show you which one is central atom, terminal atom, and lone pairs on the central atom. In the given example, carbon is the central atom, since it is at the center of the structure. Fluorine is the terminal atom because it surrounds the carbon and it is at the end. And lone pairs are unbonded electrons on the central atom. Although, there are also unbonded electrons that can be located on terminal atoms. In here, we will just refer to the lone pairs on the central atom. So in CF4, are there different terminal atoms? The answer is none, since all the terminal atoms is the same, that is fluorine. Okay, what about the next statement? Are there lone pair around the central atom? The answer is none. So, both statements are not true. Therefore, CF4 is non-polar. Let's take a look on another example. HCN. Are there different terminal atoms? The answer is yes, because we have hydrogen and nitrogen. Since this statement is true, therefore HCN is polar molecule. Moving on to our final example, NF3. As usual, our first question is, are there different terminal atoms? The answer is none, since all are the same, that is fluorine. What about the lone pairs on central atom? In this case, the central atom is the nitrogen. The answer is yes, there is actually one lone pair of electrons. Since one statement is true, therefore NF3 is a polar molecule. Polar and non-polar solubility experiment. I have prepared here a simple experiment to prove that polar and non-polar molecule cannot dissolve with each other, which adhere to the rule like dissolves like. Here are the materials needed. 3 clear glass, which will serve as container. 1/2 cup of water per glass. And 3 tablespoons of oil per glass. Independent variables. Same amount of oil and water. Dependent variables. Timing of mixture of oil and water, whichever comes first, or mixing at the same time. Okay, so this is the procedure. First, I'm going to mix the 1/2 cup of water and then the 3 tablespoons of oil on the first container. Observe what happens. Okay. Second, I'm going to reverse the procedure. This time, I will pour first the 3 tablespoons of oil, and then next one is the 1/2 cup of water. Observe what will happen. Okay, so for the third time, I'm going to mix the 1/2 glass of water, 1/2 cup of water, and the 3 tablespoons of oil at the same time. Observe what will happen. Okay, once again, at a closer look, for the first container, what did you observe? Did it dissolve each other? Second container, did it dissolve each other? And for the third container, did it dissolve each other? Here is the table of result based on the experiment. First container, water and oil dissolve? Yes or no? No. Second container, water and oil dissolve? No. And for the last container, water and oil dissolve? No. Here is my conclusion. Based on the experiment, we can say that water and oil do not dissolve with each other when mixed together, even though we change the timing of its mixture. Since it follows the principle like dissolves like, or polar molecule dissolves with polar molecule, or nonpolar molecule dissolves with nonpolar molecule. I hope that the discussion is clear and concise. At this point, please answer the what I have learned in pages 13 to 14 of your Physical Science module for grade 12. Direction. Determine the shape of the following molecule and identify if it is a polar or non-polar molecule. Please use your periodic table of elements to get the electronegativity value and the molecular geometry chart to predict the shape of the molecule. The time starts now. additional activities, answer page 16 of your module. Instruction: you are responsible for knowing the name and chemical formula of the common household chemicals. Example, water. Its chemical formula is H2O. Congratulations! We are now finished with our session for today. Remember, with great knowledge comes great power, and with great power comes great responsibility. Again, I am Junji Saborboro. Thank you for your active participation.
SDO Cauayan City, naglilingkod para sa kabataang Pilipino.